Thank you for joining us for our lecture on the binary numbering system. So, we can start this with a simple question. What is the binary numbering system? Binary numbering system is just another way of expressing the numbers that you've come to know and love. However, instead of using the digits 0 through 9, we use the digits 0 and 1. Binary is called a base 2 numbering system. This is because it only has these 2 digits. So, what does base mean in respect to a numbering system? Well, a base 10 numbering system, like the one we currently use, has these properties. Let's look at the number 115, or 115. As you can see, there are 3 numbers. By each of them I've written their space, or what number they correspond to. So 5 is in the ones place, 1 is in the tens place, and 1 is in the hundreds place. How can we convert this to something useful for a base 10 numbering system? Well, if we look, we realize that these numbers are multiplied by 10 each time. So 1 times 10 will get a 10, and 10 times 10 will get to the hundreds. So if we look over here, we can see that I've written out what this actually means. We have 5 in the ones place, so it's 5 times 10 to the 0, or 1, is equal to 5. 1 times 10 to the 1 is equal to 10. And 1 times 10 to the 2 is equal to 100. You could do this with any number that you know to figure out what all the spots are. As you can see, we then add up the 3 numbers, and we get 115. So now that we know how this works for a base 10 system, let's look at how it works for a base 2 system. I've written out a number in base 2, 1010. By the way, in binary, we still read from left to right, just like we would in base 10. So, base 2, all we have to do is change what number we multiply by. In this case, it goes from 10 to the power to 2 to the power. So this is the 2 to the 0, or 1's place, 2 to the 1, or 2's place, 2 to the 2, or 4's place, 2 to the 3, or 8's place. So, if we want to figure out what number this is in our standard base 10 notation, we just go 0 times 2 to the 0 is 0, 1 times 2 to the 1 is 2, 0 times 2 to the 2 is 0, and 1 times 2 to the 3 is 8. We add those numbers up, and we get 10. So, let's look at another one. This time, I haven't put the numbering system, as we will do it together. So, let's start with the first place. 1 times 2 to the 0 is 1. 0 times 2 to the 1 is 0. 1 times 2 to the 2 is 4. 1 times 2 to the 3 is 8. So if we sum these numbers all together, we get that this number is 15. Let's try one more that's a little longer. As we can see, if we add more digits, we're just going to add more multiplication steps. So we start just as before. 1 times 2 to the 0 is 1. 1 times 2 to the 1 is 2. 0 times 2 to the 2 is 0. 1 times 2 to the 3 is 8. 1 times 2 to the 4 is 16. And 1 times 2 to the 5 is 32. We add these numbers all together. 16 and 32 will get 48. 48 and 8 will be 56. 56 plus 2 is 58, and 58 plus 1 is 59. So our number is 59. So now, what happens if we want to go the other way? Say we want to convert a base 10 number to a base 2 number. Well, let's look at 17 for an example. The easiest way is to write out all the powers of 2 in descending order that are either 1 greater than and then all less than, or you can just start with those that are less than, because you can't use any of the numbers that are greater, any of the powers of 2 that are greater than your number, as we will see. So, we start with 17. 32 is greater than 17, so we can't use it. 16 is less than 17, so we can use that place. So, we say 2 to the 4 times 1 is equal to 16. And then we say we have to figure out what is left, what we haven't accounted for. So we say 17 minus 16 is equal to 1. So we put our 1 corresponding to this over here in the 16's place. We will then look at the 8's place. Can 8 go into 1? Of course not. So we put a 0. Can 4 go into 1? No. So we put a 0. Can 2 go into 1? No. So we put a 0. Can 1 go into 1? Yes. So we put a 1. This number is our binary representation of 17. And we know that we're done because we just put a 1. So we have 2 times 0 to the 1 is equal to 1. 1 minus 1 is equal to 0. Once you get this number to 0, we're all done. And we will check, using our skills from last time, that we've gotten the right number. So 2 to the 0 times 1 is equal to 1, plus 0, plus 0, plus 0, plus 2 times 4, 2 to the 4 times 1 is equal to 16. That is equal to 17. These numbers are equal. So this is our base 2 representation of 17. Let's try one more. This time, we'll do the number 20. Again, we start with our powers, or places, written out, and we then go on and figure out all of the numbers that we need to use. So, I'll wait for the camera to focus. Alright, so, we have 20. 32 is greater than 20, so we can't use that because then when we subtract it, we'd have a negative number, and we are not going to express our number as negative, and that would just be very confusing. So we go 20, 16, yes, 20, 16 can fit into 20. So 2 to the 4 times 1 is equal to 16. So in that spot, we'll put a 1, and then we will subtract 16 from 20, and we'll be left with 4. Now, 8 and 4, we can't fit 8 into 4, so we put a 0. We can fit 4 into 4, so we put a 1. So, 2 to the 2 times 1 equals 4. So we'll subtract our 4 from here, and we'll get 0. Alright, now we're done. But we have to make sure that we fill out the rest of the spots. So we have 2, put a 0, and 1. We'll put a 0. And this is our base 2 representation of our base 10, 20. To check, we'll do the same process as last time. 0 times 2 to the 0, 0. 0 times 2 to the 1 is 0. 1 times 2 to the 2 is 4. 0 times 2 to the 3 is 0. 1 times 2 to the 4 is 16. This equals 20. If you still want more examples of base 10 to base 2, or the other way around, I will put more examples on the website for you to try, with the correct answers listed.